Welcome to our channel for rprogramming. In this video, we will talk about multiple linear regression with R. So we know in a simple linear regression, there is only one explanatory variable. So when there's need to include more than one predictor variable in the linear regression, so this is called multiple linear regression. So we have seen in previous videos about polynomial regression, in which the explanatory variable is x, for example, and x squared or x cubic. So this kind of regression actually are the special case of multiple linear regression. And normally, in a multiple linear regression in R, we can use LM function. Then say on the left side of the tilde symbol, this is murder, this is the dependent variable. And on the right side, here we include 4 independent variables from dataset states. So this means use a plus sign, which means we include these 4 explanatory variables. Then after the regression is committed, we can use the summary function of this object to view the statistics in the results. So next we will show examples in rstudio, show how to perform multiple linear regression. So first we create a data frame with 5 columns from this data frame from R installation. We can show you see this data frame has 5 columns for different states in USA, the murder, population, illiteracy, income, and flows. And before we carry out the linear regression, usually we will view the correlation between the variables. So we just use COR of this data frame. This is the correlation matrix. The diagonal is 1 because the correlation with itself. So off diagonal elements represents the correlation coefficients. For example, murder and illiteracy has a positive 0.7, quite high correlation, and with income is a negative. Next, we can also plot a correlation matrix in the figure. So this is called a scatter plot matrix for the correlation. So this is murder, population, illiteracy, and the diagonal will show the density curve for these variables, and off diagonal represents a single fit line, single linear regression fit line between the variable pairs. So this is positive relation and this is negative. Then we can include these 4 variables in a correlation in a linear regression to again head these variables. Then fit equals LM murder and with 4 independent variables. So it is done with multiple linear regression. Next we use summary function. So from the summary function, first it lists these statements which we have run. Then show the residue with the minimum and first quantile median, third quantile max value of the residue. The residue is just the difference between the real observation for each Y, for each murder, and the fitted value of murder from the regression. Then Next part is the coefficient estimated. So intercept and the population illiteracy income flows. So each estimate of the coefficient represents the increase in the dependent variable with respect to 1 unit change in the independent variable, then holding all the other independent variables constant. So say illiteracy here, which means when illiteracy increase 1 unit and the murder rate will increase 4.143 units, but holding the population and income and flows to constant. And the column for standard error here, and with the t-value actually the division between these two columns. And the last part is p-value, and with a star, which means significance. So here we can see population illiteracy is significant at 0.01 level and 0 level. So these two significant, but the other two income flows are not significant. They have the p-value very large. Then the results show the residual standard error and multiple r-squared, which is the coefficient of determination, about 0.567. So this value shows about 57% of the variation in y. Here y is the murder, is explained by linear regression fitted line. And adjusted r-squared is just adjusted upon this value with respect to the parameters estimated. And F statistics shows a statistic with distribution of F distribution with 4 and 45 degrees of freedom. The p-value is very close to 0. Now this statistic shows that as a whole, the model is significant. The model has explanation power. We have done. So in next videos, we will show more complicated multiple linear regression, for example, including the interaction between variables, because here we do not include the interaction between independent variables. Thanks for watching.